Hello guys, this is Shubash and today we are going to talk about one of the problem in data structures and algorithms called as knapsack problem. Okay, today we'll be going to learn like what is a knapsack problem and what is the solution they are specifying, and we will solve one of the question, one of the knapsack problem with some example. Okay, yeah, coming to the knapsack problem. Okay, what is a knapsack problem? For example, consider you are a thief. Okay, just for the present situation, just consider you are a thief. Now you want to rob one house, and you have only one bag. Okay, you have only one bag, and that bag total weight it can hold is around like 500 kg. Okay, 500 kg or something. It can hold only 500 kg. Now what you have to do is, now what you will do, like basically we have only one bag and you can add only items into that bag. So what you will do, you will try to find the most valuable items in that house and you will add them into the bag. If you add more number of items, then the bag will just rip off and you cannot carry those items. And if you add a very less amount, then it's a loss for you. So as a thief, what you will do, you have to add the maximum, you have to add the most valuable items into that bag so that the bag weight doesn't get increased. The bag weight doesn't get increased, as well as the items should be more valuable. The cost should be more. So that is how you that is what you do when you go for robbery. In the same way, even the knapsack problem also works in a similar fashion. Even here, you will be given a particular bag. Here itself, the knapsack का मतलब है bag. Okay, you will be given a bag, and they will give you the maximum bag limit, maximum weight that a bag can hold, as W is the weight of the bag, maximum it can hold, and they will give you some of the products, like they will give you some 4 or 5 products, and they will give you the weight of each and every product as well as the cost of each and every product. So it's now your job to find the best products which can properly fit into the bag, properly fit into का मतलब है like weight should not be increased more than the limit. The total weight of the product should not increase the total weight W, and the cost should be more. These are the two things you need to consider. Okay, this is what a knapsack problem is. Okay, coming to for the knapsack problem, there are in DSA, as you know, there are different types of approaches like divide and conquer, decrease and conquer, greedy technique, and bound and branch, backtracking, exhaustive searching. There are many, but today using using all these type of solutions, all these type of techniques, they have provided some kind of a solution to the knapsack problem. Today we will be going to see the solution provided by the basic search called as basic approach called as exhaustive search. Okay, exhaustive search. Now, before we see how the exhaustive search will play an important role in the knapsack, first we'll see what is an exhaustive search. Okay, coming to exhaustive search. Sorry, sorry if my handwriting is very bad. Exhaustive search. Okay, now we'll see what is an exhaustive search. Now, exhaustive search is an you need to remember one thing. Exhaustive search is an brute force approach. It's a brute force approach. Brute force का मतलब है like brute force means like when you try to achieve something by doing a larger number of tasks, by doing a large number of tasks instead of smaller ones. You're getting my point, right? Like when you try to achieve something by doing a larger number of tasks instead of doing a small amount, instead of using a small steps or small techniques, you use large number of techniques to achieve the solution. That is what brute force mean. For example, if you want an example for brute force, consider you have you know the Facebook, right? You know, Facebook is a social media, and you have the username of your friend, username of the Facebook account of your friend. So, but you don't know password. This is a common approach. No one knows the password. You don't know the password. So what you will try to do, you will try to for I mean, like, for this particular username, you will try to add some kind of random passwords. For example, consider there are like 100 passwords, which you think among these 100 passwords, any one of the password will match the original password, or will match to this username. So what you will do, you will go first, you will try with first password 123. If it doesn't match, you will try with QWERTY. Otherwise, you will try with 1234, 123456. In this way, till 100 passwords, you keep on trying one after the other manually. So this approach, where you are performing manually one after the other, where you are where you, in order to get this success, you are trying to do the large amount of tasks. This is called as brute force. Okay, most commonly, as I told here, in the real world. Okay, while for example for a hackers, they doesn't have if they want to hack one particular account, they don't have just 100 sample passwords. They'll have some kind of a key list. Okay, in that key list there are around like lakhs and crores of passwords. So what they will do is, they'll just for this particular username, they'll try to run with all those particular one by one, with all those passwords one by one. But they are not doing it manually, they are automating it. Even though they are automating it, the approach it is choosing is brute force, because it is performing it's performing a large number of tasks, that too one by one. Okay, this is called brute force approach. Now coming to the exhaustive search. What is exhaustive search is, exhaustive search works in this way. What it does is, yeah, sorry, yeah, exhaustive search, what it does is, it will for example, for a particular problem, what it will do is, if there is a problem like I need to hack into the, consider the Facebook problem itself, I want the password of my account. So what it will do is, it will try to generate each and every technique using which you can generate the password. Okay, what it will do, exhaustive search works in this way, where if my target is to get the password of my account, of my Facebook account, you forgot or something. I know that you can tell that you can simply reset. Consider, if now I want to know the password of my Facebook account. So what you will do, you can try different techniques. Like, one is through email verification, other one is through mobile number verification, other one is through, there are different approaches. Okay, now how exhaustive search work is, exhaustive search to this problem will generate all the set of techniques, using which all technique I can get my password. It will just list down all those techniques one by one. And after that, what it will do is, for each and every technique, it will check whether it meets our requirement or not. For example, for the first technique, I want the mobile. I will try to verify using the. I'll try to get using the mobile number, but I don't have that. I don't have that particular mobile, or I don't use that particular mobile number. So you'll not get the OTP or something. So this doesn't meet our requirement. Coming to the second one, through email verification, I have the email, so it meets my requirement. In this way, from all the techniques, it will try to filter out the techniques which meet our requirement. Okay, in this way, it will for example, if there are 100 total techniques, it will try to filter out some 15 to 10 10 to 15 10 to 15 techniques which all meet our requirement. Now from this 10 to 15 techniques, it will try to search the best one based on the time it takes to get the password, along with that along with the less number of resources. Considering all these requirements, it will try to get one single technique which is best enough to get the Facebook password with respect to time, as well as with respect to many other factors. Okay, this is how an exhaustive search works. First, if there is any problem, first try to generate the solutions, or it will try to generate some solutions to that particular problem. it will filter out all the from those techniques from those solutions. It will try to filter out all the solutions which all the techniques which will meet our requirement, and from all that list which meet our requirement, we will try to get the one unit which is best. Okay, this is how an exhaustive search works. So now we will see, if we try to use the same concept even in our knapsack problem, what we will do. You have one particular weight, you have four items: item 1, item 2, item 3, item 4. Four items. So what you will do now, what is your task to do? The exhaustive search works is, for each and every technique you have to, you have to you have to get the best. I mean, sorry. You have, from all the techniques, you have to get the techniques which meet your requirement. In the same way, even here, what you have to do is, you have to, in this knapsack problem, what you have to do is, you have to select the number of items. You have to select the items which might be a best fit into that particular bag, so that that particular items does not the weight of that particular items does not exceed the maximum capacity of the bag. For example, if I keep my maximum weight as 500, okay, and item 1 is of 300 and item 2 is of 400. So if I add these two items into the bag, so my total weight is 300 plus 400, which is equals to 700. You can see that my total bag weight is 500. Now if I add the items whose total weight is 700, the bag will rip off. You cannot carry the bag will rip off and you cannot carry the items. So what you have to do is, you have to select the best items whose first thing you need, first condition is whose items weightage is lesser than total weight given, and the second condition is, you have to add the you have to try to get the most valuable items. Okay, you have to get the most valuable items. From valuable items का मतलब है cost किसका ज़्यादा होगा. Like for example, item, if I add item 1 and item 3, item 3 का cost है weight है 200. Okay, item 3 का weight है 200. Now if I add item 1 and item 3 inside the bag, it will become 300 plus 200, which is equals to 500, which means exact weight, where as I told, sorry, it must be smaller than or equal to. Okay, smaller than or equal to, you can see 500 is smaller than or equals to 500. The condition satisfies, so this is a best. You can fit this particular you can add these items in this particular bag. But the other thing, as you can see here, first condition has been met. Now the second condition is, you have to check the cost. Okay, you have to check the cost. Here the cost of this item is around like 5 rupees, and cost of this item is around like 6 rupees. So the total weight for these particular two items, for I1 and I3, the total weight is 500 and total cost is 11 rupees. Okay, this is what the total weight is and the total cost is. If you add item 1 and item 3 inside the bag, the total amount you'll get is 11 rupees. Okay, in this way, this is only for one subset. Okay, you can see this is only for two items. You can select one only, you can just add only a single item, or two items, or three items, in this way, or four items totally, or how many other items you want. Okay, add how many other items you want, but you have to check only for two conditions. First condition is, the weight should be lesser than or equal to the total weight. The total weight of items. Total weight of items should be lesser than or equal to total weight. And the second thing is, if this condition satisfies, then you have to get the items. Okay, you have to get the items which are most valuable, whose cost is more. Okay, this is how this is what you do if you go to robbery, right? Same, the robbery example also, you can consider the same robbery example here as well. Okay, so what we will do is, we will try to solve it with some cool example. Okay, I'll show you how will you get how you will get the particular items which is more valuable. using a small example. So consider my bag weight is, okay, knapsack, or you can call it as a bag as well. Yeah, consider my total bag weight is W is, consider it as 10, and I have like 4 items. Okay, let's take it very small, 4 items, otherwise the I mean like the item combination will become more. Okay, I'll take item 1, item 2, item 3, and item 4. Okay, total number of items, I have 4 items. Okay, now let's consider, these are items. Now let's consider the weight of each and every item. Weight, considering weight of item 1 is 7, weight of item 2 is 3, weight of item 3 is 4, weight of item 4 is 5. Okay, now coming to the cost, or cost, weight of item 1 is 42 rupees, 42 rupees. Weight of item 2 is 12 rupees. Item 3 is 40 rupees. And item 4 is 25 rupees. Okay. Consider this is your problem statement. Okay. This is your problem statement. They have given you 4 items whose weight is 7345, and whose cost is 42, 12, 40, and 25, and the maximum weightage, or the maximum bag size is 10. So what you have to do is, we will try to solve this problem using the exhaustive search. Okay, as I told, exhaustive search, first you need to generate all the subsets, or all the set of combinations. Like what happens if I have only item 1 and item 2? What happens if I item 1 and item 3? What happens, what will be the cost or weight if I keep item 1 and item 4? In this way you can try with all the combinations. Okay, I'll start with a very basic thing. Okay, my first subset is, you can call it a subset, or a set or something. Okay, now let's consider subset. Okay, I'll call subset only. This is my subset, and this is my weight, I mean the weight of that particular products, and after that the cost. Okay, now I'll start with a very basic thing, that is my bag is empty. I have not added anything. If I don't have anything inside my bag, if I don't have anything inside my bag, then what will be the weight of my bag? It will be 0, because I have not added anything. So it will be 0. So then if I have not added anything, then the cost will also be 0. So here it satisfied both the condition, but there is no profit. Okay, we don't have profit. Why do we go for robbery? We want profit, as well as we want money easily. Okay, so if the bag is empty, then you will get 0, nothing. Whatever the robbery attempt is totally waste. Okay, so I'll try with next. I'll try to just add one item. We'll just go in the increasing order, like adding 1 item, 2 items, 3 items, 4 items, in this way. Okay, I'll add only one item. I'll try to add item 1. If I add item 1, what is the weight of item 1? Weight of item 1 is 7. So the bag weight will be 7. The bag, I mean like the total, if the weight, the weight of the item 1 is 7. First condition, what I told, you have to check whether now the bag weight is 7. Okay, now the bag weight is 7 because I've added one product inside it. Now check the bag weight. The total bag weight is 10. Is 7 smaller than 10? Yes. The the item's weight is smaller than the total weight, I mean the maximum weight. So I will go to the second condition. My second condition is to calculate the count. Okay, I mean like calculate the cost. What is the cost of item 1? Cost of item 1 is 42. So I'll just add 42 here. So, and the other thing is, don't get to conclusion. Okay, don't get to conclusion until and unless all set of combinations are written. Okay, don't come to a conclusion that this will be the maximum weight until you write down all the set of combinations. Okay, So here since its weightage is as I told, since its weightage is less than maximum weight, and I have written the cost. So I'll try even the next item too. What will be the cost? What will be the amount I get if I add item 2? Item 2, the weight of item 2 is 3. So I'll write down 3, and the cost of item 2 is 12. You can write 12 here. And I'll try to add in the same way, I'll try to add item 3. Weight of item 3 is 4, and the cost of item 3 is 40. Okay. Next is item 4. I'll add item 4, last item. Weight of item 4 is 5. I'll add 5, and cost of item 4 is 25. Okay, so in this way we have added one product into the bag. Okay, in the same way now we will try to add two items in the bag. Okay, we'll consider the same table: subset, weight, and cost. Okay, now I'll try to add two items, okay, into the bag. That is, I'll try item 1 and item 2. Item 1 and item 2. What is the total weight? What is the weight of I1 or item 1? Item 1 weight is 7, and the item 2 weight is 3. Totally the weight of the items in the bag is 10. Now what is the total maximum weight? Maximum weight is 10. So as the first thing I told, first rule is the bag weight smaller than the is the I mean like sorry is the bag weight smaller than the maximum weight, smaller than or equal to, both will work. Okay, smaller than or equal to. Okay, since both are equal, then this is the perfect fit of items into the bag. So this is I mean like we can accept it. It will not, the bag will not rip off. So I'll just go to the second condition, that is I'll calculate the cost. The cost of item 1 is 42 rupees and item 2 is 12 rupees. So the cost has become 54. Okay, so you can see the cost of the two items is 54 and the total weight is 10, which is same as the bag weight. In this way you can even generate for other combinations as well, like I'll add item 1 and item 3. If I add item 1 and item 3, item 1 weight is 7, item 3 weight is 4, which will be what is it, 11. You can see here, I want you to listen carefully here. See here, now the weight of item 1 and item 3 is 11. As you can see, my first condition, the total weight of items has exceeded the maximum weight. Okay, 11 is not smaller than or equal to 10. So what I will do is I'll not go to the second condition. I'll not even calculate what is the cost, because if I add that particular item, the bag will rip off. So we will not use these items at all. I'll not add these items into the bag. So in such cases, we will call these kind of situations something called as not feasible. Something called as not feasible. Not feasible in the sense, like if we add those items into the bag will rip off. So we cannot, I mean the total cost will be 0 or something. Okay, it will be a loss. So we'll call that kind of a situation as, or that kind of a case as, not feasible. Now in the same way as I told, I'll try to add item 1 and I'll try with item 1 and item 4. What is the total weight of item 1 is 7 and item 4 is 5. So if I add, it will become 12. Even here you can see the weight of the items has exceeded the maximum weight. So even this situation is not feasible. Now in the same way, I'll try with item 2 and item 3. Item 2 and item 3. Item 2 weight is 3 and item 3 weight is 4. Here you can see 7. Okay. Now since the weight total weight is lesser than the maximum weight, I'll try to calculate the cost now. Now considering the cost of item 2 is 12 and item 3 is 40, so the total weight is 52. In the same way, I'll try with the other set of combinations, that is item 3 and item 3 and item 4 and item 2 and item 4. We'll try these two combinations. Okay, item 3 weight is 4 plus item 4 weight is 5, so this will become 9. Since it is feasible, we'll try to calculate the cost. The cost is 40 plus 25, this is 65. Now the next set of combinations, which is item 2 and item 4. Item 2 weight is 3 and item 4 weight is 5. Okay, so it will become 8. It is feasible. Item 3 sorry, cost is 40. Okay, just a minute, sorry. Item 3 cost is 40 plus item 4 cost is 25. Sorry, item 3 cost is 40 and item 2 I have to consider, sorry, item 2 cost is 12 and item 4 cost is 25, so this becomes 37. Okay, now in the same way, try for different combinations, like I'll try for 3 set of items, that is I1, I2 and I3. If I try to do this one, the total weight I'll get for all these three products or items, I'll get the total weight as 14. Since the weight is not since the total weight has exceeded the maximum weight, it is not feasible. I'll write it as NF. Okay, and not feasible. In the same way, I'll try for item 1, item 2 and item 4. If I try this combination, the maximum weight I'll get is 15. So you can the total weight I'll get is 15. Since 15 is greater than 10, so it is not feasible. And I'll try the next combination as well, which is item 1, item 3 and item 4. I'll try. If I try this combination, the weightage will be 16. So since the maximum weight is only 10, since it is exceeded, it is not feasible. And I'll try with the next combination, item 2, item 3 and item 4. Now this will become total weight will become 12. It will become 12, and since the maximum weight has exceeded, not feasible. And the final combination is all the 4 products, item 1, item 2, item 3 and item 4. If I add up all the weights, it will become 19. The total weight is 19. Since it has exceeded, it is not feasible. As you can see, I have generated all the subsets. Okay, I have generated all the subsets. Now what my work is, from all these particular, if I add these set of items, you can see there are some items, there are some combinations which are not feasible. There are some combinations which will work. So now what your work is, since first step for every combination is done, now your second step is, and your final step is, from all these sets which are feasible का मतलब है for whom you have calculated the cost. From all these cost, find the best set whose cost is more. You can see here the cost is 45, 25. Here 42 is bigger, and here 42, here 65 is bigger. 65 is bigger here. We'll see if 65, if anything exceeds 65. No, nothing. Here it's not feasible. So 65 is the maximum amount you can get by adding the products into the particular bag. So this is the best subset. Okay, this is the best subset, or this is the best products. By adding them into the bag, you will get 65 rupees. Okay, you will get the 65 rupees. Now this is how you have solved. This is how we solve knapsack problem using exhaustive search. First thing, generating all the combinations, from them, writing out which all meet our requirement. Our requirement is the weight should not total weight should not increase. So we are selecting all the subsets whose weightage is lesser than the maximum limit, lesser than or equal to maximum limit. So from these all feasible set, last thing is I'll select the subset, or I'll select the combination whose cost is more. Okay, in this way, this is how the knapsack problem works with the exhaustive search. Okay, remember the first three steps: generate all the combinations, select all the combinations which meet our requirement, and the last one is select the best combination whose cost is more. Okay, this is how an exhaustive search. This is what the exhaustive search approach for knapsack problem. So, coming to the complexity. Okay, coming to the complexity for this particular problem, an exhaustive search. Here you can see exhaustive search will generate if there are particular n items. If there are 4 items, then now this exhaustive search approach will generate 2 power n number of combinations. 2 power n, for example, here the total items are 4. 2 power n is 2 power 4 is 16 set of combinations. You can count 1, 2, 3, 4, 5 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, you can see if there are n number of items, then the exhaustive search will generate 2 power n combination of sets. Okay, so since it generates 2 power n of sets, we can consider the complexity of this exhaustive search as omega of 2 power n. This will be the complexity. Okay, this is how you solve the knapsack problem using the exhaustive search. Okay, for this knapsack problem, there is even a better, like using other topics as well, like using backtracking and beyond and what is that? Just a minute. Sorry, using the backtracking, and there are several algorithms using which you can perform the, or you can get the best solution. Okay, this is how you generate the knapsack using exhaustive search. Thank you.